All right, let's talk about the cloud. You know, it was supposed to make everything in business simpler, right? But for so many companies, it's turned into this wild, chaotic storm of different systems, confusing bills, and spiraling costs. So today, we're going to break down exactly why that chaos happens and, more importantly, show you the blueprint for taming it.
So let's just dive right in, shall we? Why is this thing that was sold to us as simple actually so, well, chaotic? The short answer is that the cloud isn't one thing. It's not some single place up in the sky. For pretty much any modern business, it's a messy patchwork of different services, from different companies, all kind of stitched together. And that's where the trouble really begins.
Okay, so to really get our heads around this chaos, we've got to define where it's coming from. And to do that, you really have to understand two key terms that are shaping basically every company's cloud strategy today.
It all kicks off with these two ideas, hybrid cloud and multi-cloud. Now, hybrid cloud is when a company uses its own private servers, the ones in their own building, but also uses a public cloud service. It's kind of like owning your own house, but also renting a storage unit for all your extra stuff. Then you've got multi-cloud. That's when you're renting a bunch of different storage units, all from different companies, like using Amazon Web Services, Microsoft Azure, and Google Cloud all at the same time. And guess what? Most big companies today do both, and that creates one seriously complex web.
So you're juggling all this stuff. What's the actual headache? Well, it creates these four huge problems. First, every cloud has its own unique dashboard, its own rules, so your teams get siloed. Then, your security rules get all inconsistent, which is a huge risk. And the skills aren't portable. An expert in Amazon's cloud might be totally lost in Google's cloud. It's just a recipe for inefficiency.
So how on earth do you fix this mess? Imagine you've got this amazing orchestra, but every single musician is playing from a different sheet of music. It would be total chaos, right? You don't fire the musicians. You go out and you hire a conductor. And in the cloud world, that conductor is a new type of software platform. And that conductor in the tech world is what we call a Unified Cloud Management System, or UCMS for short. People often call it a single pane of glass, and that's a perfect description. It's one dashboard that lets you see and control everything. This software sits right on top of all your different clouds and gives you one consistent way to manage, automate, and secure the whole shebang. It's literally designed to bring order to the chaos. And look, this isn't some small niche issue we're talking about. This is a massive, massive deal. The cloud market is gigantic, and as you can see, North America alone makes up more than half of it. All of this crazy growth just means more complexity and a much bigger need for a system like a UCMS to keep it all from spinning out of control.
Okay, a UCMS sounds pretty good on paper, but how does it actually pull this off? To get that, we need to peek under the hood at its architecture. It all comes down to a really clever way of splitting up the work.
Think about it like this. Every cloud system has two distinct parts, or planes. You've got the control plane and the data plane. The control plane is the architect. It's where you draw up all the blueprints, designing what you're going to build. The data plane is the actual building itself. It's where all the action happens, with data and traffic flowing through. A UCMS works its magic by taking charge of the control plane across all your different clouds.
But how does it speak all those different languages? Well, there's a secret ingredient, a piece of magic inside the UCMS called the Cloud Resource Abstraction Layer, or CRAL. And the best way to think about it is as a universal translator for the cloud.
This slide just lays it out perfectly. The problem, right, is that every cloud vendor, Amazon, Microsoft, Google, has its own unique language, its own set of commands, called an API. So the CRAL steps in and acts like a brilliant translator. Your team gives one simple command to the UCMS, and the CRAL translates that into the specific language each cloud needs to hear. The result? Your engineers only have to learn one system to control everything. It's a total game changer.
All right, so we know how it works. Now for the payoff. Why would you even bother with all this? Well, a UCMS isn't just about being neat and tidy. It's about making your entire cloud operation fundamentally better, smarter, safer, and cheaper.
First up, let's talk money. A USCMS can make your cloud way cheaper by plugging into this practice called FinOps, which stands for Financial Operations. It's really a cultural thing. It's about getting engineers, the people actually writing the code, to take ownership of how much it costs to run. The USCMS makes this possible by giving them real-time dashboards and alerts that show them, hey, that feature you just built, here's exactly how much it costs per hour. Suddenly, cost becomes just another metric for success.
Next up, security.
It makes your cloud safer through a really smart idea called shift-left security. The thinking is simple, right? It's way cheaper and easier to fix a tiny crack in a building's foundation than it is to fix a giant crack in a 50-story skyscraper after it's already built. Shifting left just means moving those security checks as early as possible in the building process.
And this is where it all clicks together. Remember that control plane, the architect's blueprint? The UCMS acts like an automated security inspector that checks every single one of those blueprints. It scans every configuration against your company's security rules before anything gets built, catching flaws long before they ever become a real danger. And third, a UCMS makes your whole operation smarter by being, well, a little strict. It enforces a very clear life cycle for every single thing you create in the cloud. From the second a server is born to the day it's retired and wiped clean, its entire life is tracked. This discipline is what prevents stuff from being forgotten about, which, trust me, is a massive source of wasted money and security holes.
And this quote just hits the nail on the head. In the cloud, you pay for what you use, period. So if an engineer starts up a server to run a quick test and then forgets to shut it down, well, that server just keeps running, and the meter just keeps ticking, forever. A UCMS automates that cleanup, saving an incredible amount of money.
Okay, so we've covered how a UCMS can wrangle the chaos of today. But what's next? Where is all of this technology heading? Well, the future isn't just about managing complexity anymore. It's about intelligently predicting it. Right now, for a lot of companies, cloud management is all about reacting. A red light flashes on a dashboard, an alarm goes off saying a server is overloaded, and a team of people has to scramble to figure out what's wrong and fix it. It works, but it's not exactly efficient.
But the future, the next generation of these systems, they're not going to wait for the fire alarm to go off. They'll be powered by AI that analyzes trends and says, hey, I predict this server is going to be overloaded in about 10 minutes. Then it will automatically add more power to prevent the problem before it ever even happens.
And this big shift has a name, of course, AI Ops. It's all about baking artificial intelligence and machine learning right into the core of the management platform. The UCMS is evolving from just being a dashboard you look at into an intelligent partner that helps you make decisions.
Now, for this AI to do its job, it needs data. Lots of it. It builds a complete picture of a system's health by looking at what we call the 3 pillars of observability. First, you have metrics, the numbers, like CPU usage, that tell the AI what is happening. Then you have logs, which are like diary entries that explain why it happened. And finally, traces, which show the exact path a request took through your system, telling you where a slowdown occurred. By putting all 3 together, the AI can make some incredibly smart, proactive moves.
And that brings us to one last really big thought. As these powerful AI ops systems start to automate more and more the day-to-day grind, what does that mean for us, for human ingenuity? The role of the IT pro is going to have to change. They're going to shift from being the pilots who have to manually fly the plane to being the architects who design the entire automated air traffic control system. It's a really fascinating shift from reaction to true invention. Thanks for tuning in.